Hi, I'm Philip Myman. I'm an associate professor of analytics and finance at the University of Bridgeport and the chief analytics officer for Vantage Sports. And my talk is about sports and esports analytics. The really nice thing about using Mathematica in a new field, which is something I hope you all do, is no one else does it. I don't think there's any other human being on earth who uses Mathematica or Wolfram language for sports or esports. And if you can find an industry or a sub-industry or niche like that, boy, how great is that for you, right? Because all of these tools that look like magic to everybody else are, easy for you to do. So as I'm walking through this, whether you're interested in sports or not, you can try to think how you can apply the same sorts of things to any other industry, medicine, health, whatever. So sports analytics has changed in the past few years. And if you haven't kept up with it, what you may think is that it's still sort of stuck in the Bill James era of baseball and using regressions to try to figure out on-base percentage and things like that. That was a huge revolution at Moneyball, which was now 10 years ago. That was a huge revolution. It changed the world. It changed the sport. People became more quantitative, more analytical. But there's only so much you can do with linear regression, right? I mean, who are we kidding? The future is much more data. It's not just box scores, but like fine-grained data points like LeBron James is standing at this point at this time, then 1/125th of a second later, he's moved 1/4 of an inch or whatever, like really fine-grained data for which you need to be able to manage large-scale data and do machine learning and all the other things and visualizations and interactivity that Mathematica and Wolfram language are fantastic at. I'll give you some examples of the stuff that I've built, and you'll see, like, in any other language, it would be virtually impossible. So here's an example. So what is the optical tracking data? Every NBA stadium has 29 stadiums, 30 teams. They have 6 cameras located above the court that are tracking all 10 players at the same time using like this Israeli missile tracking technology, using the center of mass so you know where everybody is. Right? It's happening 25 times per second. So each game is about 40 megabytes. It's about 50 gigabytes of data per season. Now, between us, that's not big data, right? We're not talking like Facebook terabytes, exabytes, petabytes, whatever. It's 50 gigabytes. But it doesn't fit into Excel. So everybody who's ever been hired in sports analytics over the past 10, 20 years, they don't know what to do, right? It doesn't fit. And how can you visualize it? So here's an example. Let me actually, if I have it up, I thought I did. Let's see if this works. You can make a little video. So you can interact with it, obviously, right? You can go, this is one play, one basketball play. Here are the 5 players on offense, the path they took, and you can go back and forward and see where they were and where the ball is bouncing and who is it passed to. At the bottom, you can do certain things, which is the acceleration, how much the guy is moving per second, acceleration, deceleration. Obviously, you hover over a person that says who it is, who's the other guy. You can add the defensive players and see how they move over time. You can add the referees and see where they are. They actually don't make the referee data available anymore because they don't want people tracking referees or doing referee analytics, but you can switch to a different play. You can see what happened, who did what over here. Okay, great. Fantastic. Another thing you can do, so any programming language can do a 3D histogram, fine, that's no big deal. But imagine either of those plots without the basketball rim there. Right? It's nothing, right? You don't really understand what it is. The fact that you can integrate a graphic that you can quickly build yourself, like here, make a rectangle, make a cylinder, make a whatever, suddenly adds so much context. So the one on the left, just to explain what this is, all locations of all players for that particular season on the half court, where were they? And you can see the coaches have gotten the memo about Analytics 1.0. You should take the long 3-pointers at the wings. That's the best place to sit and take 3-pointers, no question. Anyone who disagrees is a dinosaur, like Phil Jackson of the Knicks, right? So he thinks threes are bad, right? Threes. But they're great. If you can get those open shots, those are great shots. The rest of the league, basically, and Phil Jackson too, I'm just kidding, obviously is a huge proponent of it too. But what if you now restrict it to places where people accelerate? Those are all locations. On the right is where people are accelerating at least half a G. All of those accelerations and decelerations don't happen around the corner. You don't just sit, you don't just fidget there, right? You stand still for the 3-pointer. All of your accelerations or decelerations are in the paint, right? You're setting a pick or you're cutting to the basket. So you can compare those two of them together, and that makes quick. Let me give you just a very quick rundown of a bunch of other tools you can build, and think about how much interactivity and visualization adds. You're trying to communicate to general managers and owners who historically don't really understand analytics. They don't trust analytics. They think it's trying to take their jobs. They think you're a nerd and they're a jock. Right? There's a huge clash. But if you can give them a tool so that they can extract the information that they want, so that they can keep asking the questions, and so you want to make the cycle of question asking and answering really short. Right now, in most organizations, in any industry, in your industry, in your business, if you have a question about your data, it usually takes at least a day, if not a week, to get an answer, right? Let's look at all of our bank branches and see which customers have been with us the longest for each particular branch. Okay, so it's an SQL query, but you have to find the guy who knows it, gets the data, gets the SQL query done. If you want to visualize it, that's another 3 weeks. Now, suppose you get an answer back. Now you want to say, oh, I wanted to change a little filter. Forget it. At some point, you're not even going to ask the question anymore. Right? It just takes too long to get an answer. But if you have a tool like this is a rebounds. Where do rebounds go? You see the rectangle. This one's not interactive, unfortunately, just a snapshot. But if you, in the real world, it is interactive. So you put that rectangle anywhere you want. Here's another example. And you can see where the shots taken from that rectangle, where they end up, where they're rebounded, right, for missed shots. So if you're taking from the left wing, most of the shots, you can see where the rim is, it tends to go to the other side. And this is a rule of thumb that basketball people have known for generations, right? If you're going to position for rebound, 60% of the time it's going to go on the opposite side. But now you have exactly, right? If you're drawing up a play, it's nice to know that if I have a great three-point shooter on the wing, where should I locate my best offensive rebound? Well, it should be about 6 feet out from the rim. Whereas if you're taking it here, then it's more spread out. And you have the colors. You can hover over it, and you can click it, and it'll say, this is the shot that happened. Here's who was taken by. Here's who was rebounded by. And now a coach isn't reliant on you. There's no more friction between, oh, my God, this analytics guy's telling me stuff I don't want to hear. No, now it's, oh, this guy, whoever he is, he built me a tool. I have a tool. Great. Now I can ask any question I want. I can design whatever I want, whatever play I want. Here's another example for shooting. Obviously, lots of different things you could do with it, but tons of. This is just a distance from the x-axis is the distance away from the hoop that you are, from the rim, and what is the average for all the people chosen in that particular year of their field goal percentage, their effective field goal percentage. So 3-pointers count 1.5 times as much as regular field goals. So you can see the best thing is to dunk it. Surprise, surprise, right? If you're right there and you put it in, good for you. You have about a 70% chance of getting it in, because obviously there's some defenders there and everything. Then it drops off sharply till about 10 feet, and then it's flat for about 20. That's the mid-range game that people tell you shouldn't really rely on, right? Because that's about a 40% field goal percentage, not very good. But then you take a step back, and suddenly that big gap, those are 3-pointers. Why? You're still shooting the same percentage, but you're getting 50% more bonus. Right? You put things visually like this, who can argue? Even Phil Jackson. You can look at one shot, how it later led to another shot, or look at all of the makes and where they tended to happen, just a frequency thing. This is the most complicated thing I built. It's for post-ups. It's way too complicated, but the basic idea is when you're doing a post-up, how did you get the ball? Was it passed in or did you dribble in and back up? When you shot, was it a make like a green or a miss for the red, or a pass out with the blue? Where were you on the left block, right block, points per possessions? These kinds of interactive tools, imagine building this for your industry, for your clients, for people that you work with, right? If they can get their hands on it, boy, you're doing a great job, because then you're not providing answers, you're providing tools, and everyone loves a tool provider. Here's another example. So this is a paper I wrote that provided everything online for free. It automated general managers. It makes general managers, dinosaurs, a thing of the past. They should be replaced with robots, right? Because if we have machine learning that's better at humans in chess, in Jeopardy, in Go, right? Now deep learning with Go, that's it. Go is solved. Forget it. But no. Figuring out which athletes to put on the court, that's beyond the scope of any computer program on earth, right? That's way too complicated. It's not. It's very simple. The interesting thing about mathematics is the hardest parts that you would think objectively, you might think, oh, I have to make a complicated machine learning model. That's one line, right? It's just classified. Pick a couple parameters. Everything else is just presenting the information, convincing people. Here's how much you lost out because you didn't follow this model. You can, if you draft, okay, machine learning. Here's a problem with machine learning. Not a problem, but a problem. A problem with machine learning is it's a black box, right? What's the biggest thing? Oh, I can't use your machine. I don't know what's going into it. With a regression, it's beautiful. I know exactly what each coefficient is, how much it contributes. A black box, I don't know what's going on. You do know what's going on. Here's one way you can tell people what's going on. You build a model, And then you show them the inputs. These are all the inputs, right? How old the guy is, how many games he's played, and this is from college. What was his wingspan, what was his standing reach, his max vertical jump, what position does he play, all that stuff, fine. And it tells you, this is for Kawhi Leonard. Who is he most similar to back when he was drafted? What is his projections? Great. Black box. Not a black box, because if you make each one of these editable, just a simple drop-down menu, right? Now you can suddenly get anyone, it's a tool, and you can see, well, what if I don't believe a particular number of him? If I think his defensive win shares should have been not 4.6, but 3.2, which is the third quartile. I'll click it, I'll get a new number. Boom, now I get a sense. Now it's a pushback, right? Now I have this, it's a real emotional connection to the model. It's no longer a black box, it's my black box, and I can understand my black box and fiddle with it. Does that make sense? I think building a tool like this, just a one-off pricer, going from your inputs to your outputs, where you can adjust them with knobs or however you want, now people can believe it. Right? It doesn't feel like magic. It just feels like, I don't understand everything, but for the particular guys, if I have a different belief, I can see what it looks like. Let me go to esports now. Because so another nice, you could build tools like trades, right? Type in people's names or whatever, and it's like a little menu button. It can evaluate everything for you. Let's do some esports. Who's here has heard of esports? Oh, good for you. So esports, I hadn't heard of them a year ago. I mean, you kind of hear of it. What is that, video games, people playing Pac-Man or something, right? No, esports are huge. It's huge. If you've never heard of them, or if you've kind of think it's just video games, no, this is an industry that in a few years or decades, at some point, it'll overshadow all physical sports. Stadiums get sold out where people come in, pay a ticket, buy popcorn, hot dogs, beers, and watch the computer screen. They watch 5 people here, 5 people there, typing and pounding away, and you just watch what happens. Most games are interactive team games. The biggest game of all is League of Legends. Anyone here play League of Legends? Yes? What's your rank? Gold. Nice. I'm a bronzy. I'm still working my way up. Gold is very good. Bronze is where most of the garbage players are like me, so you're a good player. League of Legends is a 5-on-5 game where you're playing against 3 different lanes. It's kind of like capture the flag. You have to get some objectives and so on. And you can confirm this, the analytics for League of Legends are ridiculous. All you really know is how many kills you got, how many times you died, how many towers you got, really, really small level stuff. So one of the things we've been doing at Vantage is creating all sorts of new data. And then analyzing it. So here's one nice way of looking at things. One important thing when you're creating a team is your team composition. How do you work together with your teammates? This is an example. If we partner with a lot of the professional teams. For all of the compositions, we can figure out which ones you're best at. Look how nice this graph is. And this is about a couple lines of Mathematica code, right? It's a paired histogram, and you put a little things over here. By the way, if you've never tried something like this, the way this works is on the right, you have the total number, right? So you have 17 tank for the red team versus 13 tank. That means it's a net 4. So you put the 4 in the middle. Now you can easily and visually scan down and see who's winning what. Because sometimes a paired histogram, you can't really tell immediately which one's bigger. We've also created a win probability model. Live, in-game, you can tell how many times you've died and they've died, how many turrets you took, how many dragons, whatever, and it'll immediately tell you have a probability of winning of 45%. This is really useful at the 20-minute mark because that's the earliest you can forfeit. So if your probability of winning is like 6% at that point, you can tell your teammates and they'll be like, okay, fine, let's play another game. This would be now much easier with version 11. You can make callouts. You can see how your win probability is going, changing over time. Right? What was the big jump down? What was the big gap up? What happened? The biggest takeaway, though, if I could tell you, is what I end up doing with Mathematica a lot for finance, for analytics, for everything, is doing the back end work, the machine learning, whatever, but then providing a website. So sometimes it's a cloud deploy kind of thing where it's interactive, fine. But sometimes it's just pre-computing a lot of different graphics and packaging them so they look nice together. So here's one example. Let me put it in a different. This is a game I played in July. Timo, if you know, Timo is cancer. Everyone hates Timo. People like killing Timo. And I gave them that opportunity by dying a lot. And all of this stuff, this is the entire website, right? It's just made for Mathematica. It just runs on the back end, spits out all this stuff, and then incorporates just a template of a simple index.html and, makes little videos, whatever you want. This is how the fog of war has changed, what you've seen, what they've seen. Again, none of this is available anywhere else, but with Mathematica, it's pretty easy to do. So let me give you another example. So if you're in a team fight, this is not data you can get from the core Riot or League of Legends or anything. So here I'm one guy against two guys. You can click through, and it shows me all the times I've died. So let's look at one time. Here, this is a 13-second video of me dying. I'm the little guy, Timo, right there. That's Vantage Edge, man, that's me. So I'm just kind of wandering around. Everything looks fine. It's, oh my God, 2 people. Maybe I'll make it out. You think I'll make it this time? Come on, little dude. Come on, you can make it. You just gotta, a little more. Oh, that's it. So that's one tool. What other examples? Sometimes you can build a tool that incorporates, this is a cloud deployed version. Let me show you an example of this. So you put in your, what's called a summoner name or your in-game name. What's your name in the game, right? You don't really have a real human name. The first thing it does is a form page. So it spits out just a list of your recent games. Okay, so let's look at my recent game. I was again a Timo. What this is doing now, this is just a series of hyperlinks in a form page, but each hyperlink links to another API cloud deployed, which itself goes out to a bunch of different websites to get the professional builds, how would a professional have played Timo, and compares it to how I actually played Timo. Here's what the professionals would have purchased in terms of their items, and here's the garbage I bought instead. Right, so I got one right basically out of 6. Right, I'm terrible. I'm a really bad player. I'll never be gold. I hope someday, but. Another one, this one takes a little time, but the basic idea behind this one is you can put in, so you have different people, you're trying to make a team, right? So suppose we were able to play together. Riot won't even let us rank up together because he's too good, right? You have to be within like one tier. I can't even play with him. Maybe someday. But if you're playing with 5 people, you put in their names here together, you'll see it'll automatically go through all their history, what are your most favorite played champs, and of those, all of those possible combinations, which ones give the highest win probability. So now you know what you should play against the other team. We've built other tools based on drafting and banning and all these other things, where, again, the hard stuff, oh, I'm a chief analytics officer, I have to go sit down and think about models. It's one line, right? It's classified, it's nothing. The hardest part is making the websites look pretty, right? Put the icon here, make it a little bold, you know? Here's an example of that whole paper I put about automated general manager. Everything is free online now. No GM has an excuse not to have an excellent team. The last thing I want to show you is we'll do something live. Let's do some live esports analytics. So part of this I've already done, but then we'll try something I've never done. One quick thing, you know, so sometimes you want to do classify on every possibility, right? All the methods. The simplest way to do that is you go to classify, find all the methods, where they at. Here they are. Select it. It makes a little list, right? Same as that. You paste it in, you get the first of each one, and boom, you have the list. That's the nicest way to do it. Training and test data. Let's analyze the classify for every possible method. Now you may notice the drop -2 and think, what's going on? For some reason, random forest breaks in 11.1. It just shuts down the whole kernel. I don't know what's going on. It's a little too random of a forest. All right, and it's monitoring, so it's almost done. It's unsupported vector machine, which is the last one. Then we can see how accurate and precise they are. And the confusion matrix plot. So we're looking for a diagonal of really deep red and everything else kind of not so much red. Let's see how it looks. Okay, well, orange is good too. So 1500 versus 300. The accuracy is 85%. You can see it's good across both, but Markov didn't do as well. It's right more like 60%. Remember, so what are we trying to predict here? I should have mentioned. This is all of the stats that we calculate for one particular guy. When he's playing a game, at the end of the game, he has a certain amount of kills, a certain amount of deaths, a certain amount of assists, a certain amount of wards that he's placed, a certain amount of minions that he's killed, a lot of different statistics. But he's just one guy out of 10 on the Rift, right? The fields of justice where the game is played. One guy out of 10. It's like looking at one basketball player's end of game statistics and trying to predict whether his team won the game, right? You can have a great game, but you lost, right? Michael Jordan was famous for doing that, but then he started winning, so it's a bad example. He's probably the most winningest player ever. So it's amazing. Getting 50% is trivial, right? A coin flip. Getting 60% is not so great, but you can get 80%. Now, what happens, this is something interesting, if you do it automatic, if you don't tell it what method to use. If you don't tell it what method to use, in this case, oh, it changed it, used nearest neighbors. But if you, before it had chosen logistic regression, what I wanted to have shown you is when you do it both ways, just something to bear in mind, the automatically chosen method, even if it chooses the method that you chose, can give you a different result. Can give you a slightly different result. So the one on the right is if you chose logistic regression. The one on the left, it was automatic with logistic regression. It's a little bit different, just a little bit different.
Why is that?
I don't know. I think it's, I don't know, I'll send them a ticket, we'll see what it is. But it may just be while it's doing automatic, it's trying to, maybe there's a slightly different, it's trying to, maybe it throws away a few data points to try to figure out which would be the best one. But it doesn't really throw them away because the total is still the same. So I don't really know why. It should be the same ultimately, right? Because it's logistic regression. I mean, where you're going to go. I mean, there is some randomness involved, but if you redo both of them, you get the exact same results. So there's not that much randomness. All right, great. Any questions?